Now, there are a couple different ways to check this. One is using a graphing calculator. So, just to get a general idea, if let's say we had some function, let's just make it linear to be simple about it, and we're looking for its inverse, well, all inverse functions reflect across the line y equals x. So if I draw in the line y equals x, the inverse to this function will be a mirror image on the other side. So this is a very rough picture, so it's not going to be perfect. But you get the general idea that it's going to be just a mirror image across that line there. And notice they will always intersect the inverse function and the regular function. Let me denote these. This is f of x, and the green one is f inverse of x. They will always intersect at the line y equals x because when you switch x and y at that point, it doesn't affect anything. So if this was the point 2 comma 2 and you switch x and y, they are still both 2 and 2. So you will always see this geometric symmetry here, and you can check this using a graphing calculator. So let's use a calculator just to look at this. And I've already inputted the original function here. So if we go to the y equals button, let me clear this. We have the original function in, and then we're also going to graph y equals x. So here's what the original function looks like. It's a rational function. It does not exist at an x value of -3. And now we just need to type in our new inverse function. And we also need to highlight the y equals x graph. So we have that as well to compare it. And so we'll put it in parentheses for the numerator. That's 3x plus 1, close parentheses. Now we use division for our fraction. Open parentheses, 2 minus x. And hopefully it will be that mirror image. So let's graph this. And you can see the visual symmetry here, that the blue curve and the black curve are mirror images of each other across this red line, where the red line is y equals x. So this is certainly one way to check that you're on the right path. And another way to check is just checking if between the two functions that the x and the y values were indeed switched. So let's trace so that we can go along the graph, and let's just pick a value on the blue curve. That's the original one. Say that when x is 1, y is 0.25 or 1/4. Now on the black curve, it should be the opposite. When you plug in 0.25 for the x value, the y value will be 1. So let's go up to that curve. We're going to plug in 0.25. And if we get back 1, we know we did this correctly. And we did. So that means that this is definitely the right answer. Now that second way of checking, you can actually do that by hand. So you don't need a graphing calculator to actually check these. You can do it by yourself. So to do that by ourselves, let's check this. And we're just going to pick some x value and plug it into the original function to get some point on this graph. And let's be simple. Let's just plug in 0. So when we plug in 0 to our function g, we get 0 minus 1, so that's -1, and we get 0 plus 3, which is 3. So this goes through the point 0 minus 1/3. So our inverse function should go through this point switched. So if we plug in -1/3 here, we should get back 0. So let's quickly do that. So plugging in -1/3 to this inverse function, we have 3 times -1/3 plus 1, all divided by 2 minus -1/3, or 2 plus 1/3. Let me just move over just a bit more. And notice that in the top, the 3's would cancel, and we get -1 plus 1. So we get 0 over 2 and 1/3, which we could rewrite as 7/3. But 0 divided by anything is 0. So this does equal 0, which means that our inverse function does go through the point we were hoping for. It goes through at -1/3, 0. And so we checked it, and it made sense, which means we can feel very confident that this is in fact the correct equation for the inverse function. So It is sometimes a lot of work to check it that way. It's not too bad, but it is some extra steps. But if you need to be certain that this is correct, then you really should be checking your work, either using this method or just graphing it with the calculator. So let's work on another example problem, and let me just make some space here.